Hello all. In today's session, we are going to discuss about the canonical and standard form in digital electronics. So, before moving on to the canonical form, we need to understand the terms like min term and max term. So, let us understand what are min terms and what are max terms, and then let us understand what is the canonical form and the standard form. So, if I consider min terms and max terms, so min terms are nothing but the product terms, or it is also called as standard product. If we consider max term, so it is a sum term, or sometimes it is called as standard sum. Yes. So now if you consider two variables x and y, and if I try to write the min terms and max term for this, so then we will get, so let us write the possible combinations first, 0, 0, 0, 1, 1, 0, 1, 1. So min term and max term. So let us consider min terms first. So min terms are nothing but the product terms. So product is nothing but AND operation. So for AND operation, we know that AND gate output is 1 only when both the inputs are logic 1. Since I have 0, 0, so I need to complement both. Otherwise I am not going to get the logic 1 in case of AND operation. Therefore min term for this combination is x bar dot y bar. Next I have 0, 1. 0, 1 is x bar dot y. Next I have 1, 0. 1, 0 is expressed as x y bar, and at last we have x, that is 1, 1. So we have to write it as x into y. These are the min terms, and the symbols what we use in order to represent min terms are m0, m1, m2, m3. Similarly, let us write, so the max terms for these four combinations. Max term is nothing but the sum term. Sum is nothing but OR operation. Therefore, so for OR operation, here we are going to consider logic 0 instead of logic 1 in the sense. So the output will be assumed as logic 0. So here the symbol, if it is 0, the value of the symbol is 0, then it will be represented in the original form. If the value of the symbol is 1, then it will be represented in its complement form. Therefore, here I have 0, 0, but since it is written for logic 0 output, so we are writing it as x plus y. If I give 0 for x as well as y to a OR gate, the output of the OR gate is 0. So now let us move on to the next combination. I have 0, 1 for the next. So here 0 will be written as original signal, whereas 1 will be written as the complement. So here we had written for the output equal to 1. We are assuming that the function or the logic operation or output is equal to 1 in this case, whereas we are writing this max term, the sum term or standard sum for the logic 0 output. Therefore, in order to get logic 0 output, we are supposed to give x as 0 and y as 0 for an OR gate. Again, so x is 0 but y is 1, so I have complemented. So that the difference you need to observe. So here what we are writing, we are complementing if the signal value is 0, but there we are writing the signal complemented form if the signal value is 1. Next we have 1, 0. 1, 0 is written as x bar plus y. So at last we have 1, 1 which is written as x bar plus y bar. So this is for two variables. Now let us see for three variables. Next let us consider canonical form. So first before we could see what are the types we have in canonical form, let us understand what is canonical form. Canonical form is a Boolean expression, it's a form of a Boolean expression which contains all the variables in each and every term either in its original or complemented form. Okay. So, now to understand that, let us write the expression for F1 and F2 and let us understand. So, what is the canonical expression? So, remember each and every term should contain all the literals or all the variables what we have in a function either in its original or complemented form. Now, let us see the types of canonical forms what we have. So, in canonical we have canonical sum of product and then second type is canonical product of sum, or this can also be written as sum of min terms, or this can also be called as sum of product of max terms. So, what is canonical SOP? Canonical SOP is the sum of min terms. So, min terms we have seen how to write the min terms for all the combinations if you consider 3 variables. So, the sum of min terms which will result in logic 1 for a particular function, that expression is called as canonical sum of product. Remember that should not be a reduced one. So, the original expression whatever we write from the truth table, so that expression is called as canonical SOP. And similarly coming to the POS form, that is product of sum form. So, if you write an expression in terms of max terms and that is from the truth table, before we could reduce it, so whatever the form we have, original expression we have, so that expression is called as canonical product of sum, if it is written for logic 0. So, now let me consider example whatever I have written. I have taken 3 variable function and here I have mentioned 2 functions F1 and F2. So, here you can observe I have written logic 1 in certain places. Those are the input combinations which will give you logic 1 for the output variable. Then F2 I have written, so you can observe, so in certain places I have written logic 1. Now, let me consider the function F1 first. So, function F1 can be expressed, let me do one thing. So, first I will express that in the, that is using min terms I will express, later I will express using max term, yes. So, if I write F1 in terms of min term, so how to express? So, we have logic 1 for this combination. So, in min term form while writing min term, so remember signal having 0 is represented as complement, signal having 1 is represented in its original form. So, there we have logic 1. So, the input combination we have is x bar, y bar, z. So, other than this we have logic 1 in other 2 places, therefore, we need to consider those also. So, while considering those we are going to use OR gate. This combination will result in logic 1 for the output, or so if this is not there, then next combination we have is this one, that is x, y bar, z bar, that is the next combination we have. At last we have x, y, z. So, these are the combinations which will result in logic 1 for the output, either this or this or this. So, this is called as sum of product terms, and you can observe each and every product contains the 3 variables either in its original or complemented form. So, this is called as canonical sum of product. Next we have, as I said, I am going to write both, using min term and max term, and so using the symbols this can be expressed as, this is M1, so if you want you can refer the previous table what I gave. So, this is M1, next we have M2, M3, M4, next is M4, last one is M7, or we have one more form of representing this, that is using the summation symbol. So, in this we are going to write the row numbers, so within this bracket we are going to use the summation symbol, then followed by 1, 4, 7. So, this is also one of the form of representing the sum of products. So, now as I said, let me consider how to represent F1 using max term. So if you observe the table, you can observe we have logic 0 in 5 places, because logic 1 we have in 3 places. So logic 0 we have in 5 places. So now I will write F1 using the max term notation. Yes, so we have 0 in first row. So input is x plus y plus 0. Okay. Then we have, okay, here we have logic 0. So the input combination is x, y bar, z. X, y bar, z. Next again we have here. So third term is x plus y bar plus z bar. Okay. So we are done with the 3 terms. We have 2 more logic zeros here. So x bar plus y plus z bar. Next is x bar plus y bar plus z. So this is how we write using the product of sum. So this is canonical product of sum form. Okay. So POS, in short we call it as canonical POS. This can also be written using the max term notation. Okay. As well as we have another representation. Let us see. So this is M0 dot, it is a product. Okay. M0 dot M2 dot M3 dot M5 dot M6, okay, which is written in another form as pi of 0 comma 2 comma 3 comma 5 comma 6. Yes, so this is how we represent in, okay, using the canonical POS form. The same function similarly we can write for F2. Okay. One more, okay, point you need to observe is, so here we have cell number 1, 4 and 7. There we have 0, 2, 3, 5 and 6. So if you observe, so this canonical SOP, okay, is complement of canonical POS and vice versa. Next let us see conversion between canonical form. So in order to understand this, I have considered an example here. So I have written certain function which is a, okay, variable which is a 3 variable function and variables are x, y, z. Now let us write this function using the min term notation, that is summation of. So if you see the cell numbers, so we have 1, 3, 5 and 7. Okay. So now if I want to take the complement of this, let me consider f dash. So complement of this is nothing but just we need to negate these bits. Okay. So we have 1, 0, 1, 0, 1, 0, 1, 0 for this. Now let me write f dash of ABC using this notation. So f dash of ABC is again summation, because we are expressing using the min term notation. So we have 0, 2, 4 and 6. So you can observe here. So complement of a function is just you need to write the cell numbers which are missing in the original function. Yes. Now let us take the complement of this. Okay. Before that, let me express this as summation of the min terms M0 plus M2 plus M4 plus M6. Okay. Now let me take the complement of this in order to get the f itself, f in another form. Okay. So f, here whatever I am writing, this is complement of this f. Okay. Is equal to M0, M2, M4, M6. Okay. Complement of this. Let us expand this. Okay. Using the De Morgan's theorem. So this becomes M0 dash plus M2 dash, M4 dash, M6 dash. Okay, sorry, since we are using De Morgan's, plus must be changed as dot M0 dash dot M2 dash dot M4 dash dot M6 dash. Okay. Now let me write the expression for this and then expand using, okay, again the De Morgan's. So m naught can be written as, so we have 0 0 0, therefore x bar y bar z bar whole dash dot m2 is 0 1 0, so x bar y z bar whole complement, m4 is 1 0 0, so x y bar z bar, m6 is x y z bar. Okay. Yes. Now let us expand this. This can be written as x plus y plus z. Let me write using the maximum notation also. This is nothing but m0 m naught, okay, dot, this is x plus y bar plus z. Next is x bar plus y plus z. Last one is x bar plus y bar plus z. Okay. Yes. So this is m naught. Next is, so we have 0 1 0, which is nothing but m2. Next is m4 and last term is m6. So here if you observe, okay, see, compare these two rows and we can conclude that mj dash is equal to mj. And as I said, f in another form, okay, that is f of ABC can be expressed as m naught, m2, m4, m6, so which can also be written as pi of 0, 2, 4, 6. So if you, okay, consider this, so any min term, okay, with subscript j, if you take the complement of any min term with the subscript j, then it is going to give you the max term with same subscript. Okay. So that is the conclusion we have here. So if you observe, f of ABC in another form is nothing but the canonical POS form. So here we have canonical SOP form. So in order to convert that into canonical POS, so we can use this procedure. Okay. This is about the conversion of or conversion between canonical form. So now we need to understand, so how to convert a given function from standard form to canonical form. Therefore first let us understand what is standard form. So standard form is the expression, okay, which is in reduced form. Canonical form, whatever we have, whatever we write, okay, so that is for the truth table given, we are going to consider that canonical form and we are going to use the Boolean laws and postulates, okay, the theorems whatever we have, using those we are going to reduce the Boolean expression, and that expression is called as standard form. And in standard form also we have two types, one is standard SOP, the other one is standard POS. So standard SOP is the reduced, okay, expression, canonical expression, using canonical expression and using the rules, theorems, postulates whatever we have, we are going to reduce that, and the reduced canonical SOP is called as standard SOP form. Similarly, reduced canonical, okay, POS what we are going to get, that is called as standard POS. Now next I am going to consider two examples wherein we will be having the standard form, reduced form. So reduced in the sense we will be having less number of gates, okay, or sometimes it may be less number of literals itself. So it need not have to contain each and every product term what we have, need not have to contain all the variables in original or the complemented form. It is true for the POS also. If you consider standard POS form, in standard POS form it is not necessary to have all the literals in original or the complemented form. So we can have the reduced one in the sense we can have less number of inputs, less number of gates. Okay. So now let us, okay, consider two examples and let us understand how to convert the standard form given expression from the standard form to, okay, the canonical form. Okay. As a first example, I have considered this function So in the given function, if you observe, we have f is equal to a plus b dash c. So here we have two product terms. So this can be assumed as a into 1, okay, plus b dash c is another product term. So this is standard SOP form. This is standard SOP form. Now let us convert this into the canonical SOP form. So as we discussed, canonical must contain the all the variables, okay. As we discussed, the canonical must contain all the variables, okay, in each and every minterm, okay, in each and every product term. Now if you observe, so here we have two product terms. In the first product term, so we have only one variable, but as overall function, if you observe, we have three variables. So which are those? A, B, C. So if you consider the first literal, so first, okay, the product what we have only one. So it is missing two variables, okay, and the second term is missing one variable, okay. Yes. Now, okay, let us introduce the missing variables and let us, okay, convert this function into the canonical form. So now let me consider the first term. First term is A. So this can be written as A into, okay, 1 as I said. So in place of 1 I am introducing this missing literal, okay. So in place of 1 I am introducing this missing literal. So first I have introduced only 1. So you can have 2, but you need to be careful while writing the terms. So I am going to continue with this. I am going to multiply AB, then I am going to, okay, multiply A to the next also. AB plus AB dash. Now one more literal is missing. I am going to consider this is multiplied by 1 and 1 will be replaced by the next variable. So we have AB plus AB dash. So 1 can be replaced by C plus C dash. Further we need to multiply ABC plus ABC dash plus AB dash C plus AB dash C dash, okay. So we have 4 terms. So from the first term, so if you observe, so this is the, okay, the canonical form we can have for this product term. Now let us consider the second one. So second term is B dash C. B dash C further, okay, as I said, this can be assumed as it is multiplied by 1 and 1 can be replaced by A, like A plus A dash, because from, okay, the theorems and the postulates we have A plus A dash is equal to 1. Therefore, so we can write like this, B dash C, okay, into A plus A dash. Further A B dash C plus A dash B dash C. Therefore, the function f can be written like this. So first term is expanded and canonical form is this one. Okay, second term A B dash C plus A dash B dash C. Now further, so we can remove the repeated terms. So we need to check for the repeated terms. Do we have any? Yes, we have here. See, A B dash C is repeated twice. We know that x plus x is equal to x. Using that we can, okay, write further, okay, we can express this using the minterm notation. So here we have, this is 111, so M7. Next we have 110 is M6. Next we have 101 is M5. Next we have 100 is M4. Here we have 0, 0, 1, which is nothing but M1. So you can rearrange in the increasing order because we usually write in that format. So M1 is first, next M4, 5, M6, M7. Okay. So it can also be written using the summation notation as 1, 4, 5, 6, 7. So this is how, okay, we convert a given standard function into its canonical form. And now let us transfer this to the truth table. So here the variables we have are A, B, C and function is F. Okay. Let me consider all the possible combinations. So here if you observe in logic, okay, that is in the first row we have 0, next we have 1, next 2 again is 0, next 4, 5, 6, 7 are logic ones. So this is how, okay, we convert the standard form into its canonical, and this is how to write the truth table for that particular, okay, expression of the function whatever we have obtained. Now let us consider canonical POS form. This is an example for canonical SOP. Now let me take another example for canonical POS. Okay. Next example we have is f is equal to xy plus x dash z. So here we need to, okay, express it as a product of max term, but given is a min term. Okay. So therefore now let us consider f and let us transfer or transform this into the product of max term. Okay. That is in before we could convert into canonical. So first let us have it this in POS form. Okay. Yes. We have xy. So using distributive law, so this can be considered as one variable. Using this, okay, we can write like this: xy plus x dash into xy plus z. So using distributive, I have expressed, okay, this in this form. Further, this can be, okay, considered as first variable, and this can be considered as yz. Using that, we can write this as x dash plus x. Again, I am using the distributive law: x dash plus x, okay, into x dash plus y. So again, this is, see here, z plus x, z plus y. Okay. So using distributive law twice, I have expressed this function like this. Now let me reduce. Here if you observe, we have x plus x dash which is equal to 1. You can, okay, avoid, and you can write, okay, the function as x dash plus y into x plus z into y plus z. So this is the POS form. Now let us convert this into canonical POS. This is standard POS. So now as we discussed, we need to write the missing literals for each and every, okay, the term what we have. So here if you observe, okay, we have two variables in each and every term, okay, sum term. So now, yes, so we should, okay, add another term, that is the missing literal, such that it should not change the, okay, original expression. So x dash plus y we have, plus I am going to write z into z dash which is equal to 0. So 0 or anything will be same as this function. Therefore, so I am going to write like this. Again, here we have missing literal as y dash. At last we have x dash as missing literal. So now if you expand, so using the distributive law, you can write, okay, this as x dash y z. This can be, okay, x dash y z dash. Next, x plus y plus z, x plus y plus z dash. Last one, x plus y plus z, x dash plus y plus z. See? Yes. One second. So this is x, y dash, z. Okay, x, y, z, x dash, y, z. Yes, again we need to search for the repeated terms. Do we have any here? Yes, x plus, y plus, okay, z has been repeated. And even the last term is repeated. So, x plus a, okay, x into x is also x. Therefore, we can write this as x dash plus, okay, y plus z, x dash plus y plus z dash, x plus y plus z, yes, that's all. The last two terms are repeated. Further, this can be written as, see, this is 0, 1, 1. 0, 1, 1 is, no, sorry, this is max term notation. Therefore, this is 1, this is 0, 0. So, this is M4, this is 1, okay, this is 0. 1, 0, 1 is M5. Next we have M0. Next we have, this is 0, 1, 0. 0, 1, 0 is M2. Rearranging this, we get F is equal to M0, M2, M4, M5. Okay. Further, using the pi notation, we can represent this as, okay, and truth table if you want to represent, so we can have like this. So we have x, y, z as variable and f as, okay, the function. So here 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. Yes. Now if you consider the f, so f we know that, so it is a POS form. Therefore, so these are the cells where we have logic 0. Therefore, in row number 0 we need to write logic 0. Next, okay, in row number 2 we need to write logic 0. Then in 4 and 5 again we need to write logic 0. 6 and 2nd will be logic 1. So that is the truth table for this given function. This is how we convert the standard POS form into the canonical POS form. That's all for today's class. Thank you.